So members, this is the summary of our lecture today about statistics. So we said the statistics involves data collection, analysis of the data, interpretation, which means drawing insights from the data or making sense of the data, presentation of the data and results, plus organization of the data and the results itself. So this was well understood as the basic definition of statistics. So categories of statistics that we talked about involve descriptive statistics, inferential statistics, and other categories. But these two shall be dealt with in our discussion. So, and finally, during this discussion, more details will be given on descriptive statistics, and inferential statistics will be the next after this lecture. So descriptive statistics include measure of central tendency and measure of dispersion. Now, what is the measure of central tendency? It means we are calculating for mean, we are calculating for mode, we are calculating for median, and mean is basically the average, mode is the most common data point, and median is the middle data point. Then measure of dispersion, we are talking about range, we are talking about variance and standard deviation. Range is the difference between the maximum and minimum of the data points. Then the variance is the distance of the data points from the mean. This is going to be the sum of these differences squared divided by the number of the data points. Then the standard deviation is going to be the square root of variance. Now, the formula used in descriptive statistics, we are going to begin with ungrouped data. So what is mean for ungrouped data? It is equal to sum of x, which are the data points, divided by the number of the data points. We are saying x represent the data points, and this can be the age of students in a certain class. It can be height of students doing higher diploma. It can be the weight of mothers in a hospital. It can be the weight of born babies in a particular hospital. Then n is the number of the data points in the sample that we have selected. What about mode? Mode is the most common data point, and if it is ungrouped data, we can just look at what is the most common. If, for example, we have 1, 2, 3, 2, 4, so here you see the most common is 2, and therefore that will be our mode. What is variance? Variance, we said, is the sum of the data points each squared divided by the number of the data points minus mean squared. Mean is the sum of the data points divided by their number. So if we square and we subtract it from the sum of the data points squared individually divided by n, we shall get variance. It can also be obtained from sum of x minus mean, everything squared divided by the number of the data points. And as we said earlier on, standard deviation, sigma is going to be the square root of variance. So we move and look at median. Median, we said you arrange the data set in ascending order or descending order, cancel the first and the last data points, cancel the second and second last data points, etc., etc., until you remain with either 1 in the middle or 2. So if it is 1, that will be your median. If they are 2, we said you add them and divide it by 2. The value that you will get will be the median of the data sample. Now, we are taking an example for ungrouped data. So we are having height of particular individuals from a given society. So it is represented by x. So it is 100 centimeter, 50 centimeter, 100 centimeter, 55, 60, 100, 110, 90. The number of data points, when you count them, they are 8. So we want to calculate for the different parameters of descriptive statistics, and one of them is mean. We said just add, and the total you divide it by the number of the data points, and what you will get will be your mean. What about mode? We said mode is the most common. So when I check among these data points, the most common is 100. Therefore, your mode is 100 centimeters. What about median? We said you arrange in ascending order or descending order, then you cancel them. Cancel the first and the last. The second with the second last. The third with the third last. Then what will remain in the middle will give you the median. But now in our case, we are remaining with the 2. So add the 2 divided by 2. What you will get is going to be your median. So for variance and standard deviation, we need to get x squared. So if we get x squared, we need first to write our x, then we'll write x squared. 50 squared is 2500. 55 squared, you get this up to 110 squared, which will give you 12100. So when I look for the variance, it will be sum of x squared divided by n, which I got here. My sum of x squared would give you 59, would give you 325. So I will bring it here, divided by n, which is 8 minus. Sum of x is also given here, 665. So I also put it out of n, I square. When I square and get the difference, I have this value. Then my standard deviation is that, because the square root of variance. Range, obviously, will be maximum minus minimum. And the maximum is 110, the minimum is 50. So it will give you 60 centimeters. Now we are rushing to discuss the grouped data. Grouped data, we are beginning with mean. So it will be the sum of fx divided by sum of f, whereby f is the frequency or the number of times that data point appears. So this is what we call mean. Now what about variance of x? It would be sum of fx squared divided by sum of f. You get x, you square it, then you multiply by its frequency. Then you sum. So you create a column of fx squared, and then you sum, then divided by sum of f, and then take away. This is the same as mean. So you square mean, you subtract it from this value, and what you will get will give you variance. What is standard deviation? Square root of variance, as we have earlier on discussed. What is mode? Mode, we said, is the data point that appears most, and then we shall need to first understand what is the class width, class size, class interval, which are the same, and it's what will build our concept of determining mode. We have the different classes where we have class of, for example, a data point to another data point. So if we are looking at this is A to B, that is one kind of a class. A to less B, A to less or equal to X to less or equal to B. This is going to give you another type of a class. Then to A, then B2. All these are different classes. So you need to understand what kind of a class they have given you, and then see how to treat it in your computation. For simplicity, we are going to take this kind of class. So we have, for example, 14 to 19, and if we are given such and the class is uniform, we can always subtract 14 point, we can always subtract from 14 0 0.5 and add the 0 0.5 to 19. So what we will have is 13.5 to 19.5. If we are asked to again calculate for class interval, it will be that 19.5 minus 14.5. Or if not, we are unable to do that, we can get the class limit, upper class limit minus lower class limit. So these are the class limits. 14 and 19 are the class limits. So the lower class limit is 14, upper class limit is 19. Now, if I'm asked to get the class interval, that will be 19 minus 14 plus 1. So if I have 5 here, then I add 1, I will get 6. It's the same as getting 19.5 minus 13.5, and I will get the same 5. So let's go to next. So here, that introduces us to the formulae that we use. Now for mode, we have the lower class boundary plus delta 1 divided by delta 1 plus delta 2 times C. This would give you the mode. So what we do, we have to get the LB, which is the lower class boundary of the model class. C is the class width, delta 1 is the model class minus frequency before it, delta 2 is the model class, model class frequency minus frequency after it. Then how do we get or determine the model class? That model class is going to be the class with the highest frequency. So this must be noted. The class with the highest frequency is the one that will give us the model class. And that's where we shall determine what our model frequency is, what is the frequency before, the frequency after, and the class width. So what is median? Median also is calculated by this value, by this formula. So LB plus sum of frequency divided by 2 minus cumulative frequency before divided by frequency of the median class times the class width of the median class. So lower class boundary of the median class is LB, cumulative frequency before. The median class is CFB, then C, we can also determine it. Then frequency of the median class, we can determine it. What is now our struggle is to get the median class. So the median class is always going to be determined by a value equivalent to n out of 2. So n out of 2 value lies in a particular class. So that class is what we shall call the median class. So we will always go to cumulative frequency. That's why you obtain or what column you're going to use to determine this class. So if, for example, your n is 12 and you get n out of 2 as 6, you go to cumulative frequency values, a value that is close to 6, in most cases slightly higher than 6 or equal to 6 is what is going to be corresponding to the median class. Then you take it up and then read off the lower class boundary, get the class width, get the model frequency, the model frequency before, and the model frequency after. Then you will be good to go to determine the median. An example would be this. If we are talking about students doing higher diploma mathematics, then we have the frequency distribution of this kind. These are classes. Now, the frequencies are down. So we have age and we have the frequency. So if the frequency is down and is given as that, We are told to construct a frequency distribution table and determine mean, mode, median, variance of x, standard deviation, quartiles. Shall also need to determine the quartiles. 2, 1, and 2, 3. So the frequency distribution table is here. So you write your data class as given, get the mid value, which is x, then the f is also given. So just to get this 19, you get 18 plus 20 divided by 2, you get that. 21 plus 23 divided by 2, you get that. 24 minus 26 divided by 2, you get this. 27 plus 29 divided by 2, you get that. Then the frequency is already given. Cumulative frequency, you write this one here. Then you keep on accumulating. Get 2 plus 1, you write 3 here. 5 plus 3, you get 8. 4 plus 8, you get 12. So this is how you get the cumulative frequency. The very first value of cumulative frequency is the same as that of frequency. Then you get that 2 plus 1, you write here. 5 plus 3, you write here. 4 plus 8, you write here. And the value that you get last here is the same as the sum of frequency. If the sum of frequency is 12, then the last value of cumulative frequency must also be 12. Then how do we get f of x? You get frequency times x. Just get this value of f. 1 times 19, you get 19. 2 times 22, you get 44. 5 times 25, you get 125. 4 times 28, you get 112. Then fx squared, you get x squared, which is 19 squared times 1, which is f. You write 22 squared, which is x squared. Then times f. F is 2. You write here. 25 squared, you multiply by 5. 28 squared, multiply by 5. You write here. That's boundary. We said if you have such a kind of distribution, and then you have your classes in this manner, then you have to get 18 minus 0.5, then you add 0.5 on 20. This is because these values are to 0 decimal places. If it is to 1 decimal places, then the value would change. If it is to 2 decimal places, then the value you add here and subtract here would change. So, but here we have 0 decimal places, and therefore it will be 0.5. So I get 0.5 I subtract it here, I will get 17.5, 20.5, 20.5, 23.5, 23.5, 26.5, up to 29.5. Then from there, I said I add fx squared, I add fx, I have already the sum of f. So I proceed to calculate for my mean, and that is how I get it. The formula we have already discussed it. For variance, this is how I get it. I use the same formula that we used above. That we talked about above. Sum of fx squared divided by sum of f minus the square of mean. So the var is that. And the standard deviation is also as here because it is the square root of variance. What is mode? Mode, we said lower class boundary of the model class plus sigma 1, delta 1 divided by delta 1 plus delta 2 times c. We said the model class is that class with the highest frequency. So when we check in our frequency distribution table, we find that the one with the highest frequency is this, and the frequency of that class is that. The lower class boundary will therefore be this. The C, which is the upper class boundary minus lower class boundary, will be that. Then we substitute for delta 1. Delta 1 we said is frequency of the model class minus frequency before it. divided by frequency of the model class minus frequency before it plus frequency of the model class minus frequency after it. Then you'll get that value. Then substitute in the formula for mode, and your mode will be this. The next one is to get median. Median, we said the median class has to be obtained by this n out of tooth value, and when we do that, we realize our n is 12 divided by 2, we get 6. So we go to the frequency distribution table, the value which is close to 6. Usually, in the frequency distribution table, we shall choose the cumulative frequency value which is either exactly equal to the value that we have obtained or slightly higher than that. And the value that we are taking is going to be within this class that is corresponding to 8, because 8 is near to 6 compared to 12. So the value that you're going to take is 23.5 to 26.5. The cumulative frequency before is going to be 3. And the frequency of the median class is going to be 5. The class boundary we are saying here, and therefore we are going to take the lower class boundary as 23.5. So you go and substitute all that in this formula, and then your median will be 25.3 years. Then the other issue is to look at the quartiles. So the data set can be grouped into the first quartile, the second quartile, the third quartile, the fourth quartile. From the first quartile to the third quartile is what is always very important. 2-1 is the first quartile, and it represents the first quarter. Then 2-2 also represent the second quarter, and that is equivalent to median. So 2-2 is the same as median. 2-1 minus 2-3 is what we call interquartile range. Now, how do we get the 2-1? 2-1 is the same as L2-1 plus 1 out of 4 n minus cumulative frequency before the first quartile class divided by the frequency of the first quartile class times the class width of the first quartile class. 2-3 is what? The lower class boundary of the third quartile class plus 3 out of 4 n minus cumulative frequency before the third quartile class divided by the frequency of the third quartile class times the class width of the third quartile class. How to calculate for those values, especially to identify the 2-1 class? Of course, we said it is a quarter nth value. So go to cumulative frequency and get that value. So if n is 12 divided by 4, you get 3. So you go to the cumulative frequency distribution table and find out which class corresponds to 3 on the column of cumulative frequency. So we have found out that when we check there, when 3 corresponds to 21, 23, and that is 20.5 to 23.5. So the value we're interested in is 20.5. And what is the cumulative frequency before that? It will be 1. What is the frequency of that class? It will be 2. So you just go substitute in there and get your value. Then choose 3 the same way. 3 out of 4 times 12, you get the 9th value. So the 9th value goes to cumulative frequency. Look at the value which is close to 9. The value which is close to 9, but slightly at least slightly above 9 is going to be 12, because in this is 8, and you see 8 is outside the range of 9. So if it was maybe 10, we would have taken this. So we are going to take 12. So the class boundary is 26.5 to that. And the value we're interested in is that. What about the frequency of the third quartile class? It will be 4. The cumulative frequency before the third quartile will be 8. So we substitute in all those values, and then we shall be able to get the third quartile class. Substituting here, and finally your third quartile class is equal to that. Then we said Q2 is the same as median, and therefore if you are to calculate for it, you'll find that you can use this formula LQ2 plus n out of 2 minus the cumulative frequency before, divided by the frequency of the Q2 class, then times the class width. You'll find your answer is equivalent to median. Then the interquartile range, obviously, you would get this Q3 minus Q1. That's all that we discussed in this lecture. Wish you a good time.